Route servers. It's an interesting subject for IXPs in particular, and for many of you who are our members, you certainly seem to like them. But when you have two IXPs that merge together, or you have a group of IXPs in a given region that merge together, it creates challenges in terms of what route servers are you going to deploy, or what route servers are you going to keep, and maybe you start it all over and you have a whole new concept. So what drives it? You have these VLANs, or most of us do, that we have to put together if we're going to integrate our exchanges. And in some cities where you have large IXPs merging together, they're going to merge their VLANs and do funky things. Having a constant or consistent peering VLAN and consistent route servers is important. So what platforms are out there? There's quite a few route servers that are available, and I didn't list the hardware vendor-based route servers that are coming out, right now, really. Cisco has a beta out there, and I know that Juniper is working on one as well. So the common platforms that exchanges use today: Bird, OpenBGPD, Quagga, and Lynx has their own version of Quagga that they've had rewritten, which is significantly more stable than the original Quagga. OSs, I add that in there because there's significant dependencies for given route servers on the OS that you use. So it's important to consider that when you're going through your selection, you need to also work on your platform selection as well. And one of the most important things that I've seen working on the route servers has been as you add more features to your route servers, your config gets significantly more complicated, which really drives auto-provisioning. Provisioning a highly complicated multi-rib route server by hand is not fun. So, features. Customers or members drive features. We then get to implement them and support them. Common ones that are out there: community support, so that you can local pref routes in and out of the route server, black hole routes. At this point in time, anybody that's not supporting AS4 for 32-bit ASNs is a little bit behind the curve. V6 is a must. We see a lot more increase in prefixes on the V6 route servers. And then you get into the filtering to support ASset. This gets a little bit more into the auto-provisioning aspect of things, how you deal with these features. ASset filtering is pretty easy. You can scrape that data and do that. But a lot of customers may not necessarily want certain ASs that they have in their IRR to be advertised via the route server. So there's ways to deal with that. Some IXPs actually have portals where you can go in and specifically allow prefixes, remove prefixes, or AS sets, AS paths below that to add flexibility for the members so that they can more easily manipulate the connections and the paths on the route server connections. And the big one that we've seen moving forward has been multi-rib support, so that you can really manipulate every peer that's connected to your route server's data, so that they can choose if they want to be on the route servers, but they don't want to peer with certain people that are connected to the route servers. They can easily not accept those routes into their rib and not advertise their routes back out to certain peers' ribs as well. So that's a feature that we've seen a lot of requests for. So you're merged. What do you do? A lot of this stuff sounds cliche, and as an engineer, it took me a little bit of time to warm up to it. You really do need to sit down and analyze what features you need from your route servers, because a lot of times you may get one member or two members that say, we want this, 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 and this, and the list could be quite long, but the rest of your membership might not want that. You need to really sit down and see how much development time is going to be taken to get certain features out there. And getting all of this information before you start implementing your route servers is very useful. And then choosing your route server software. With so many variations out there, not everyone uses the same platform. For example, Equinix in the Equinix Classic markets uses OpenBGPD, but in the Switch and Data Classic markets we use Bird. So that's one example. In Europe, it's significantly different. There's reasons why each given ISP chooses to go with the platform that they want, and a lot of times it's a personal preference. And then to go dive into what operating systems are you going to use to support your route servers. This is, sometimes your IT group in a large organization might drive that because they might only support Linux, or they might only support FreeBSD or what have you. So you have a limited choice. Well, that definitely has a ramification on what route server software you can run. If you can only use Linux, you really don't want to run OpenBGPD on it. It doesn't work very well. So that's there. There's and you get into on certain kernel versions and what have you, issues with MD5 and TTL security. So not only do you need to dive into what operating systems you're going to run, what kernel versions you're going to do, and that will have a direct effect on what route server software you can actually deploy. So as we were talking about security, there's a lot that goes into it. MD5 is a feature that many customers request, though in this day and age I'm not necessarily sure how overly useful it is. On the IXP side, it opens a security issue in itself, in that we have to track your MD5 keys, because we don't want everybody knowing your MD5 key. So that we have to have a secure database that keeps all that information in itself. BGP TTL security, a very useful feature on route servers, and definitely ties back to which kernel versions you're going with and what platforms you're running. Not all platforms will support, or kernel versions will support TTL security properly. Communities is a complicated one on the configuration side, because it really drives a significant amount of length of config to support a lot of communities that customers want. Customers not only want local pref, ability to local pref, ability to black hole routes of theirs, but sometimes they would like to have the ability to black hole routes of their peers so that they don't receive traffic from them or send traffic to them. And then when you deal with a multi-rib scenario, how you pass those communities back and forth between the pipes to each table definitely can add some complexity when you're dealing with generating a complete config periodically, refreshing it so that your auto-provisioning and your prefix-based filters, or ASPath filters, keep up. And that can drive the length of your config. We've seen some configs in our lab that have been 5 megs of just text. And for the parser of the route server to deal with that, it can take a long time for your route server to start up or refresh. IRR filtering. This is truly, in terms of config length, the number one thing that drives it. And in terms of parsing, it's what really drives the CPU on your route servers. If you have a new peer that comes on that adds in 100,000 prefixes into your table, even with aggregation, you still take a significant CPU hit on that platform while that's going on. The real question that I have to the community is, do you really care if we filter on the route servers? As the service provider should probably be filtering to us. Does that level of security need to be there? Is that a trust that you want us to have? Is that a feature that you really want us to continue to maintain? If not, it certainly makes our life a lot easier. So OS issues. I covered it briefly. OpenBSD is pretty much the only thing you want to run OpenBGPD on. There's ports that you can run it on Linux, or older versions that will run on FreeBSD, or you can hack the bejesus out of it and make a current version work. But you're going to lose a lot of the features when you get there. So that's definitely a big one. And then for MD5, pretty much on every platform, there's issues with MD5 working properly. MD5 like getting forgotten. If you change an MD5, it doesn't actually change. There's a plethora of stuff out there. The best advice I have for anybody who's going through this is to make sure that you test your kernels out pretty significantly before you throw this into production, because it will drive you batty at 2 o'clock in the morning when you're trying to figure out why you've changed a customer's MD5, but it doesn't actually work. So in my experiences in testing Quagga, OpenBGPD, Bird. OpenBGPD and Bird are definitely the two dominant route servers that are out there today. People that are running Quagga are generally switching. People who have switched to OpenBGPD 4.8 or Bird 1.2.5 or a Git derivative of 1.2.5 seem to be the most happy and seem to be the most stable. 1.3 should be released soon for Bird, which will have a whole bunch of fixes that will make everybody sleep better at night and make your route server actually converge significantly faster. So good things. And when you get down to the OS, I've pretty much beat on this. You know, which OS you run definitely drives which route server you can run, which features you can enable, and how stable they are. So the customers or members definitely drive all the features that we deploy, and by virtue of the fact of the number of routes that they advertise to us, certainly dictate which platforms we could choose. For AMSIX, running the old Quagga would probably not be an option for them. It would crash a lot, and Hank would have a headache. But for a small IX, that only has a few members, Quagga certainly is definitely an option for them. There's advantages to that in that it's a very Cisco-like CLI, and then the disadvantages, of course, are that it doesn't scale very well. But the one thing that we have learned is that we can't not have route servers because it's a competitive disadvantage, and many of you like the route servers. So route servers we have. Also, in terms of membership, one thing that members definitely, or customers definitely like, is a portal access to be able to manipulate the route server data. At the very least, they seem to like to be able to enable their sessions and, in some ways, manipulate their prefixes, whether it's by putting their AS set in or by actually being able to directly control which routes are added into their prefix filters from the portal. Seen it both ways. They both work fairly well, given the logistics of the auto provisioning system. So, best practices in route servers. Depending on the region, this varies greatly. A lot of regions only do AS set filtering. In North America, we do primarily prefix filtering with very limited AS set filtering. Depending on how advanced your route servers are, there's some to significant community manipulation that's allowed. Most route servers in this day and age allow auto provisioning in some way, shape, or form, and most route server deployments moving forward support multiple ribs, at least in the way that at least if a customer needs a custom rib, one's created for them in some cases. In other cases, it started out that by default, every customer has a rib and we pipe stuff back and forth between ribs. Either way works. Both have their advantages. Not having a rib per customer certainly limits your config size and your complexity, but having a rib per customer assures you the maximum flexibility for your customers or members. So, getting into the test results that we've seen for OpenBGPD versus Bird, which is the two that we're at Equinix that we're comparing. The big difference between Bird and OpenBGPD is the threading. OpenBGPD runs 3 separate processes: the parent session engine and the route decision engine, where Bird handles it all with one. It's not multi-threaded, but it has a significantly superior scheduling system for its messaging bus, which makes Bird's single process arguably significantly faster than OpenBGPD's multi-threaded process. OpenBGPD runs one config for v4, v6 all runs within the same thing. Separate config files for v4 and v6 on Bird, and it actually runs 2 separate processes. So v4 runs in its own world, v6 runs in its own world, and hopefully Thursday we can turn off the v4 process. Just kidding. The disadvantage in OpenBGPD really is that certain features and aspects of community handling is very hard to implement. In Bird, it's significantly easier. The community processing on OpenBGPD is faster. The big disadvantage I see for Bird is honestly its learning curve. The syntax is significantly different than anything else that's out there. It's not like Juniper. It's not like Cisco. It's not like OpenBGPD. It's just its own thing, and the way that you have to replicate certain functions in order to get it to work for each rib, for each pipe, what have you. There's oftentimes a lot of duplication of config that goes between to add in there to make everything work great. So I'm not going to read everything. There's a lot of stuff up there. Test cases. So for OpenBGPD, just a basic v4, no problem. Updates for MD5 with standard filters, that one definitely failed. This is OpenBGPD 4.5. So 4.8 would be, a lot of these would pass. Sessions, a lot of session stuff with long community and uninterpreted communities, uninterpreted do pass, long communities fail. So this is what we've seen. If you're interested in the methodology for these tests, I will gladly share that after the presentation with you. But in some cases, it's actually kind of convoluted and complex in how we actually derive their test cases. For Bird, it pretty much passes with flying colors. In a lot of ways, because we have a far more active development group that's involved with Bird, we can, if we've seen a problem, a bug or what have you, we can pass it to the Bird developers, and generally within 24 to 48 hours we get a patch back that's ported into the Git tree, and then at 1.2.5 we had a bunch that made it in there, and we have a bunch in 1.3 that are in there that will, when 1.3 is released. So the development staff at Bird is amazing in terms of responsiveness to get issues fixed. So as a result, you see our results are significantly better for Bird. But like anything, there's politics. So when you have two companies or two exchanges or what have you merged together, there's oftentimes difficulties with figuring out who's going to run the process of getting the route servers done, what platforms you're going to use, what IP space we're going to use, if we're going to use IXP-A's block or if we're going to use IXP-B's block, and are we just going to just use IXP-A's route servers and not B's, or B's and not A's, or are we going to come up with something all the way through? Auto provisioning versus manual provisioning. Auto provisioning is intensive in terms of development time, especially with a complex route server configuration. It can really give people headaches when you're trying to figure out why certain things don't reliably provide the correct config every time for passing that out to the route servers. Getting the route server rehashed and hopefully the changes are there. It can be time consuming, and that's definitely an issue when you're trying, in a lot of cases when two IXPs merge, you're trying to get everything done for customer day one and have everything smooth. You might not have enough time to get your end game done before you're actually ready to roll in terms of the network. But what is the end game? Beautiful new route servers, old route servers, new software, new processes. There's a lot of good questions there, and a lot of times a lot of good headaches there. But my advice to anybody who's out there doing this or looking to do this, or IXPs that are looking to merge together, is that when you're sitting down to talk through the route servers, don't be in a rush. When you get into a rush and you push things forward, you may miss features that you want. You may not get the end desired goal that is actually going to satisfy everybody's needs, and also testing. We've spent, I don't know how many hours of testing OpenBGPD and Bird and found countless bugs that could have come back to haunt us after we deployed the route servers if we just deployed them in the initial phase in the way that we were going to do it. But by testing it very, very thoroughly, when we roll out our new route server platforms, they hopefully will be ready for prime time and not crashing. Makes you happy, makes me happy, and everybody happy. Any questions? Cool. I like that.
Too thorough.
Much fun. Cool. Thanks, guys.